What's up guys, Patrick here, welcome back. Moving on to the next example. So we got the limit as x approaches 0 from the positive side of cotangent 3x times sine of 10x. So with limits, what you first want to do is do a direct substitution. Let's see what's happening with this function overall. So if we plug in 0, but from the positive side over here into this x, we'll have 3 times a very small positive number, which is going to give us a very small positive number. So we'll have cotangent 0. This is critical though. It's going to be approaching from the positive side. I'm going to show you why that's important, right? There's going to be a positive number here. And then sine of 10 times a very small positive number is going to be a very small positive number. So this is going to be sine of 0, and that's going to be positive. This is not as crucial as this. The reason why this matters, whether it's positive or negative, is because there's actually an asymptote for the cotangent graph at an x value of 0. And if you remember, just to do a quick little review here, this is pi, this is negative pi, and then this is pi over 2, this is negative pi over 2. Basically, the way the graph looks is like this. So notice as we approach 0 from the positive side, cotangent is going to approach positive infinity. But if we approach it from the negative side, then it would go towards negative infinity, right? So this function overall here is going towards positive infinity. And then sine of 0, just to kind of mix the graphs here, it doesn't matter whether you approach 0 from the positive side or from the negative side. Sine is just going to approach, this whole function is going to approach 0, right? So notice that when we do a direct substitution, we end up in this form here. That's an indeterminate product. And so what we want to do is we want to convert it, as we talked about in the previous video, to an indeterminate quotient. The question is, which of these two functions are we going to bring down to the denominator? And in my opinion, it's better to bring down this cotangent 3x to the denominator. So we could rewrite this as the limit as x approaches 0 from the positive side of sine of 10x over 1 over cotangent 3x. And the reason why is because 1 over cotangent 3x is the exact same thing as tan 3x. Okay, so just as a review, if we got tan A, that's the same as 1 over cotangent A, where A could be a variable or an expression like we have here, or we could do cotangent A equals 1 over tan A. And so the reason why I think it's better to bring this one down to the denominator is because now this converts to a primary trig ratio tan, which personally I'd rather just work with primary trig ratios than reciprocal ones. If we brought down the sign, you can do it. You're still going to get the same answer, the same final answer, but then you'd have cotangent 3x over 1 over sine of 10x, which would be cosecant 10x. So now you would have two reciprocal functions to work with. Or you could leave it as 1 over sine of 10x, but then you got to apply the quotient rule on that, and it's just, I don't know, it's just going to be more of a mess. Here, I feel like this is just easier to work with. Now, notice that when we do a direct substitution here, as x approaches 0 from the positive side, we know that that numerator is 0, right? We talked about that, sine of 0 is 0. But now notice that tan of 0 is 0 as well, right? So we took that format of where we had positive infinity times 0 and converted it to an indeterminate quotient where we have 0 over 0. This function and this function are the exact same thing. And so what we can do now, it's in this indeterminate quotient form, we could apply L'Hopital's rule. So what we would do is we would take the derivative of the top, which would be cos of 10x, or not 10x, sorry, times the derivative of 10x, which is 10, apply the chain rule, over the derivative of 10 is secant squared, keep that inner function the same, 3x, and multiply it by 3, like that. And so from here, what we could do is we can factor out the 10 over 3. So I'm going to continue this here. I'll factor out that constant, and we would have the limit as x approaches 0 from the positive side of cos of 10x, and then secant squared 3x. So what we would end up having is 10 over 3 times cos of 0 over secant squared 0, which would be 10 over 3. Cos of 0 we know is just 1. Secant squared of 0, that's like 1 over cos squared 0. And we could rewrite this as cos 0 squared. Cos 0 is 1. 1 squared is 1. 1 divided by 1 is 1. 1 divided by 1 is 1. So we just end up with 10 over 3. Right, so this limit here approaches 10 over 3. With a direct substitution, we couldn't get that number. It was an indeterminate product. Changed it to an indeterminate quotient, right? Then we were able to change this to 10. Then it's 0 over 0. We could apply L'Hopital's rule, and then when we applied it, it's just algebra from there. 10 over 3 is the final answer.